Hello friends, myself Samanvith and welcome to my channel. So today we are going to discuss about the chemical reactions and equations. So what are chemical reactions? How can we derive the equations? Okay, how does the chemical reaction occur? What are the differences between the chemical changes and the physical changes? Hold on, there are many more questions to answer. So these questions will be answered by me in this video. So watch the video till the end. So friends, here are some examples given for you. So now can you classify these examples into the physical changes and the chemical changes? Okay, first let us recall what is the exact meaning of the physical changes and the chemical changes. The physical changes are reversible changes. The chemical changes are irreversible changes. No new substances are formed in a physical change, but in a chemical change, new substances are formed. So now let us give an interesting example for each of these changes. In a physical change, tearing of paper. So you can glue this paper easily and convert it to its original state again. But in a chemical change, let us give an example, that is burning of paper. So here a new substance is formed, that is ash. So can you convert this ash back to paper? No, right? So this is an example of chemical change. So friends, now let's come back to these examples. Now let's try classifying these examples into the physical changes and the chemical changes. Alright, so now first let's get into the first example. What is it? It's the milk kept in room temperature during summers. Can you guess which type of change is this? Yes, that's right, it's a chemical change. But do you know why? It's because when the milk is kept in open during room temperature during summers, it gets converted into curd, or the fermentation of milk is involved. Hence, a new substance is formed, that is curd. You can't convert this curd back to milk, right? Hence, it is an example of chemical change. So friends, now let's get into the second example. What is it? Melting of ice. Can you guess which type of change is this? Yes, that's right. It is a simple and common example of physical change. Do you know why? Yes, it's because when the ice is melting, it gets converted into liquid, that is water. But you can easily freeze this liquid or water and get back its original state, that is ice. And hence it is a reversible change and no new substances are formed. Hence it is an example of physical change. So friends, now let's see which is the third example. An iron nail is exposed to humid atmosphere. So can you guess which type of change is this? Yes, that's right, it is a chemical change, because an iron nail gets easily oxidized and reacts with oxygen which is present in humid atmosphere. Hence, this is also known as rusting of iron. Hence, this rusted iron cannot be converted back to its original state. And here a new substance is formed, that is iron oxide or iron rust. Hence, this is an everyday example of chemical change. So now let's see the fourth example. What is it? Yes, that's right. It's the fermentation of fruits. By the way, what is fermentation of fruits? Yes, that's right. It's the ripening of fruits. So here we have a common apple. It is getting fermented. So which type of change is this? Yes, that's right. It's a chemical change. So let us know the reason behind this. Can you change the ripened fruit back to its original state? No, right? Hence, it is a common example of chemical changes. In the similar manner, we come across through many different types of changes in our everyday life, such as food is cooked, food is digested, we respire. So, can you guess which type of changes are these? Yes, you are correct. They are all chemical changes. In this video, we are going to focus only on chemical changes. So friends, here you saw many different types of chemical changes, right? So do you know what happens when there is a chemical change? Yes, You are absolutely correct. A chemical reaction is involved. So, in this video, we are also going to learn what are chemical reactions, how we can write it in a word format and also in a chemical equation format. And in the end of the video, we are also going to see how to balance the chemical equation. So friends, before we start writing the chemical equation both in the word format and also in the chemical formula format, let us perform a small activity to understand the basic characteristics of the chemical reaction. So friends, to start up with the experiment, we will need a spirit lamp, a magnesium ribbon about 3 to 4 centimeters long which is already cleaned by sandpaper, and also a watch glass and a pair of tongs. Alright, these are the basic requirements of the experiment. Before starting the experiment, a precaution that has to be taken is we must wear suitable eyeglasses, or we must keep the magnesium ribbon as much as far from our eyes. So now let us bring the magnesium ribbon near the spirit burner by using a pair of tongs. So now as you can see, the magnesium ribbon is burning with a dazzling white flame. So now as you can see, the magnesium ribbon is converting into a white powdered ash. So this white powdered ash is magnesium oxide. It is formed due to the reaction between the magnesium and the oxygen which is present in air. Alright, so this is the first experiment. Now let's get into the second experiment to understand the characteristics of the chemical reaction. So for the second experiment, we will require lead nitrate and potassium iodide solution. We will also require a conical flask or any other shape you like to store them. So now let us take the potassium iodide solution in a flask, and next let us add the lead nitrate into the solution. So now as you can see, the lead nitrate is converting into a yellow precipitate or a type of a solid. This is formed due to the reaction between the lead nitrate and the potassium iodide. So this yellow precipitate is the lead iodide, which is a byproduct of this reaction. So this is a very interesting chemical reaction. By this we can understand another characteristic of chemical reactions which I will be saying later in this video. So now let us get into the third experiment, that is the zinc granules and the dilute hydrochloric acid reaction. First let us take the dilute hydrochloric acid in a flask. Next we have to add the zinc granules inside this flask. So now what do you observe? Yes, that's right. We can observe the bubbles formation around the zinc granules. These bubbles are nothing but hydrogen gas, which is a byproduct after this reaction. So this is also a common example for chemical reactions. So now if you touch the flask, you can feel the temperature, right? So is it hotter or cooler? Yes, that's right. The flask will be hotter. So there is a temperature change in the chemical reactions. So now let us get into the basic characteristics of chemical reactions. So friends, by these three experiments, we can say that there are many different observations in which we can say that a chemical reaction is involved or not. So such observations include change in state, change in color, evolution of a gas and change in temperature. So there are many other observations in which you can see them in many other chemical reactions. Such observations include formation of a precipitate and also difference in odor or smell. So these are the basic characteristics of chemical reaction. As we observe our surroundings, we can find a lot of varieties of chemical changes and reactions. So in this video, we are going to focus on the chemical reactions and equations, and we are also learning how to symbolically represent them. So first, let us understand what are chemical equations. Previously in this video, we saw an experiment, that is the magnesium ribbon experiment. So how can we describe this reaction? One of the ways is describing it like like this. The magnesium reacts with oxygen which is present in air to produce magnesium oxide. So this description of this reaction is quite large, right? So the shorter way of writing this reaction is to write it in a word equation. So the word equation for this experiment looks something like this. It is magnesium plus oxygen gives rise to magnesium oxide. So friends, if you observe this word equation carefully, you can find out that there are mainly two parts in this equation. Those are the LHS of the equation and the RHS of the equation. That means the tail side of the arrow and the head side of the arrow. What are they called? Yes, you are absolutely correct. They are called the reactants and the products. So the reactants are those substances which interact with each other to form a new substances. But the products are those substances which are produced by the interaction of reactants. So this is the basic meaning of the reactants and the products. The arrow of this equation indicates the change of reactants into products or the direction of the reaction taking place. Alright, I hope you understood the concept, friends. A plus sign is placed between the reactants and the products. So this is all about the chemical equation. So you saw that we can write the chemical equation in the word format. So is there any simpler way to write it? Yes, there is a way to write it. It is in the form of the chemical formula format. I will be saying how to write it in this video. Chemical equations can be made more concise and useful if we use the chemical formulas and symbols instead of words. So such equations are itself known as the chemical equations. So friends, now if you recall the chemical formulas of magnesium, oxygen and magnesium oxide, this equation can be written as Mg plus O2 gives rise to MgO. Friends, now let's start counting the number of atoms of each element present in the reactants and products. First, let us see the magnesium. How many atoms of magnesium are present here? Yes, that's right. It's only one atom of magnesium. Let's get into the oxygen. How many atoms of oxygen? It's 2 because oxygen is diatomic in structure in atmosphere. Hence, in one oxygen molecule, there are 2 atoms of oxygen. Hence, the total number of atoms present in the reactants are 3. Next, let us start counting the number of atoms in the products. So, how many elements are present in the products here? Yes, that's right. It's 2. That is Mg and O, magnesium and oxygen. So, the total number of atoms present in the products is 2. So, now as you can see, the total number of atoms present in the reactants and the products are not equal. So, such equations are known as unbalanced equations or skeletal equations. So, what about the balanced equations? The type of equations which have the total number of atoms present in the reactants and the products are equal are known as the balanced equations. We can balance unbalanced equations also. So now let us see how we can balance an unbalanced equation or a skeletal equation. Mass can neither be created nor be destroyed. Hence, the total mass of the elements present in the products are equal to the total number of elements present in the reactants. The total mass of the elements does not change before and after the reaction. Hence, it is necessary to balance a skeletal equation. So friends, before we start balancing a skeletal equation, let us see how we can check whether a equation is balanced equation or an unbalanced equation. First, let us take an example of a balanced equation. So here's the chemical equation. What is it? Yes, it is zinc plus sulfuric acid gives rise to zinc sulfate plus hydrogen. That is Zn plus H2SO4 gives rise to ZnSO4 plus H2. Friends, let us now make a table to determine whether this equation is a balanced equation or an unbalanced equation. Alright. So here's the table. It must have 3 columns. That is, the first column says the name of the element. The second column says the number of atoms present in the reactants. And the third column says the number of atoms present in the product side. So now let us start filling this table. So let us begin with the first element, that is zinc. So let's write Zn here. How many atoms of zinc is present in the reactant side? It is 1. So let's write 1 here. How many atoms of zinc is present in the product side? It's 1 in the product side also. So let's write 1 here again. In the same way, let us do it for the second element, that is hydrogen. How many atoms of hydrogen is present in the reactant side? It is 2. So let's write 2 here. And now how many atoms of hydrogen is present in the product side? It is 2 again. So let's write 2 here. In the same way, we have to continue this process for the other 2 elements as well. If you complete this process perfectly, your table must look something like this. So if you observe this table carefully, you can see that there are equal number of atoms both in the reactant side and as well as in the product side. Hence, it is known as the balanced equation. So now let us try balancing a unbalanced equation. For an unbalanced equation, let us take an example, alright. So here's the example. Iron plus water gives rise to iron oxide and hydrogen gas. So in a chemical equation format, it looks like this. Fe plus H2O gives rise to Fe3O4 plus H2. So now let us start balancing this equation. To balance the equation, first we have to draw boxes around each chemical formula in the equation. We can't change anything which is inside this box. Only we can change the coefficients outside the box while balancing the chemical equation. This is the first step, friends. The second step is to list the number of atoms present in the reactant side and in the product side for each element. So this is the method that we had used for the previous example, friends, to make a table like this. So now let us hop into the third step. It is often convenient to start balancing with the compound which has the maximum number of atoms present in it. Using this criteria, we can find out that the compound Fe3O4 has the maximum number of atoms in this equation. So we are going to choose this compound. In this compound, which element has the maximum number of atoms in it? Yes, that's right, it is oxygen, O4. So first we are going to balance the element oxygen. The number of oxygen atoms in the RHS side is 4. But the number of oxygen atoms in the LHS side is just 1. So to equalize the number of atoms of oxygen, we will have to add the coefficient 4 for the water molecule, such that the one oxygen atom gets multiplied by 4, or 1 into 4 is equals to 4. Hence, now the oxygen atoms in the reactants is 4. Hence, the oxygen atoms has been balanced. The coefficient 4 is not only applied to oxygen, but it is affecting the hydrogen molecule as well. Hence, the H2 is multiplied by 4, giving rise to 8 hydrogen atoms. Now in the reactants, there are 8 hydrogen atoms, but in the products, there are only 2 hydrogen atoms. As the hydrogen molecule is independent in the product side, it is very easy to balance it now. So, by adding the coefficient 4 to H2, the hydrogen gets balanced. The only element left to balance now is iron. So now let's balance iron. In the same way, iron is independent in the reactant side. How many atoms of iron is present in the product side? It is 3. Hence, the coefficient that needs to be added to iron in the reactant side is 3. Now, as you can see, the equation has been balanced. So now, the final balanced equation is 3Fe plus 4H2O gives rise to Fe3O4 plus 4H2. So now, let us check this equation. There are 3 atoms of iron in the reactant side and 3 atoms of iron in the product side also. There are 8 hydrogen atoms in the reactants and the product side as well. There are equal number of atoms of oxygen in the equation, that is 4 and 4. Hence, the equation is balanced. So now, let us observe this equation carefully. Is there any information about the physical states in this equation? No, right? The physical states of a chemical equation are of mainly 4 types. Those are gaseous, liquid, aqueous and solid. Aqueous is a type of state where it is dissolved in water. Alright, it is a kind of a solution. So if we add the physical states for this equation, it looks like this. Here Fe is in a solid state and the 4H2O is in gaseous state. Do you know why? It is because here H2O is used as steam. Fe3O4 is also in solid state because it is iron oxide, and again 4H2 is gaseous state. There are many other chemical reactions in which the chemical reactions conditions are added above and below the arrow of the equation. Some of the examples are given here. These conditions include temperature, pressure and catalyst. Friends, now as you all know how to balance a chemical equation, can you balance this equation which I had used before? That is Mg plus O2 gives rise to MgO. Please post your answers in the comment sections below. So don't forget to hit the like button to this video and also share this video with your friends. And do hit the subscribe button to my channel to be notified about my latest videos. Thanks for watching.